So let's try and capture some of the key observations that we have seen. We have seen that the def statement is very much like an assignment statement. And the first time we encounter the def statement, we skip over the body of the function. It's just like we assigned a variable named after our function, and we set its value to the function object that was created. We don't actually execute the statements inside the function until we call that function. Now, inside the function, we have parameters, and those parameters are like local variables. You cannot access them from outside this function, so you cannot access them from the global frame, and they do not clash with any variable that's already in the global frame. So here, for example, let's try this quick experiment. Let's jump back to Python Tutor and edit this code by renaming these variables. Instead of a and b, let's give them the same name as the function's parameters. Let's call them n and m. And again, we will just replace a with n and b with m everywhere. If we forget to do one of these replacements, we will get an error message. So we must remember to do this everywhere. An IDE will help make these replacements easier. But now I'm going to show you what happens when the global frame has variables named n and m, and the function itself has local variables, namely parameters, named n and m. Let's click on Visualize Execution and execute this. So I'm going to skip ahead. To the point where n and m have already been inputted as the integers 10 and 0. Remember, they were inputted as strings, and then we converted them to ints. Now I click on Next. Observe that I'm currently in the global frame. I'm about to move to the isMultiple frame, and in the global frame I have variables n and m initialized like so. When I click on Next, I get fresh variables local to this frame. They happen to be also named n and m. The n that is local to this frame and the n that is local to the global frame, in this case, are referring to the same object. This is not because they have the same name. As we saw earlier, this was not even called n, it was called a. And you can try rerunning this experiment by renaming this to m and this to n, and you will see that just because the names of the variables are the same, that is not why they end up referring to the same object. They end up referring to the same object because the first argument was the object that the global variable n was referring to, and the local parameter n was first. So this first argument corresponds to the first parameter, and secondly, and the second argument corresponds to the second parameter. So try such experiments out. Each frame has its own local variables. If you decide to modify the variables in the global frame or modify the variables in the local frame, these are independent variables even though they happen to have the same name. We will understand this better when we see more complex functions, but it's good to see the idea first with a simple example. So the local variables cannot be accessed outside the function in which they are defined. At best, what you could do is you could return a variable, and of course what would get returned is the object that that variable is currently referring to. So keep these ideas in mind. Do go back to the Python Tutor link and rerun the example to make sure you have understood these concepts before proceeding to more complex examples.